It seems you're asking about the different types of eyesight or vision that could be related to the development of a baby during pregnancy. While eyesight secrets may refer to how the sense of sight forms in the womb, I'll interpret this to explain how the baby's eyes and vision develop and the types of vision associated with humans, particularly focusing on what happens during fetal development. 1. Development of eyes in the womb. The development of the eyes is a complex process that begins early in pregnancy. Here's how it unfolds. Weeks 4 to 5 of pregnancy, the eyes start forming as two optic grooves on either side of the brain. These optic grooves later become the optic vesicles, which will give rise to the structures that form the eye. Week 6 to 7, the lens of the eye begins to form, and the retina, the light-sensitive layer at the back of the eye, starts developing. Weeks 8 to 10, the basic structures of the eyes are mostly in place. The eyelids also start to form but remain fused until later in pregnancy. Weeks 18-20, the baby's eyes become more defined, and the retina starts to develop light sensitivity. The eyelids, however, remain closed during this time. Weeks 26-28, the baby begins opening their eyes. This is also when the retina continues maturing, which is important for proper vision. Final weeks. The eyes are mostly ready for seeing light, though newborns do not have fully developed vision right at birth. 2. Types of eyesight development during and after the womb. Human vision progresses through various types or stages. Light perception. Around the second trimester, babies in the womb can start detecting light, even though their eyes remain closed. They might react to bright light shining on the mother's belly, such as sunlight. Visual acuity. A newborn's vision is very blurry. They can only see objects that are 8 to 12 inches away. Over the first few months of life, the baby's eyesight sharpens, but true 20/20 vision typically develops by age 2. Color perception. In the womb, babies don't perceive colors as we do, but after birth, they can see high contrast colors like black, white, and red. Full color vision usually develops by around 5 months of age. Depth perception. Babies start developing depth perception after birth as their eyes work together to form a single image. This occurs in the first few months and continues to mature during early childhood. 3. Eye disorders and genetic factors. Sometimes, abnormalities can occur during the development of the eyes, leading to conditions such as congenital cataracts, clouding of the lens present at birth, amblyopia, lazy eye, a condition where one eye doesn't develop proper vision. Strabismus, crossed eyes, misalignment of the eyes. Conclusion. From light detection to full visual acuity, the development of eyesight in the womb is a gradual process. Eyesight continues to develop even after birth, as newborns initially have limited visual abilities. Is this what you meant by eyesight secrets, or were you referring to something else related to vision? If by eyesight type of secrets, you mean the different types or aspects of human vision and how they function, there are several key components to understanding vision and eyesight. These secrets or types can include various ways our eyes and brain perceive the world. I'll explain several important aspects of vision. 1. Light sensitivity, photoreception. Photoreceptor cells, rods and cones, in the retina respond to light, forming the basis of our vision. Rods, sensitive to low light levels, helping us see in dim light. Night vision. Cones, responsible for color vision and high acuity tasks like reading. There are 3 types of cones, each sensitive to different wavelengths of light: red, green, and blue. Secret. Rods help us navigate in near-dark conditions, while cones allow us to see in bright light and differentiate colors. 2. Color vision. Humans generally have trichromatic vision, meaning we perceive colors based on the combination of red, green, and blue light. Secret. Color blindness occurs when one or more types of cones are absent or not functioning properly. For example, in red-green color blindness, the red or green cones are defective. 3. Depth perception, stereopsis. Our ability to perceive the world in 3 dimensions, 3D, relies on binocular vision, where both eyes send slightly different images to the brain. The brain merges these images to create a sense of depth and distance. Secret. Closing one eye diminishes our depth perception significantly, making it harder to judge distances. 4. Peripheral vision. Peripheral vision allows us to detect movement and objects outside the direct line of sight. It's less sharp but highly sensitive to motion. Secret. Peripheral vision is key for detecting danger or sudden movement, like something approaching from the side, but it's not good at distinguishing fine details. 5. Visual acuity, clarity of vision. This refers to how sharp and clear our vision is. It's often measured by an eye chart, 20/20 vision. Secret. Visual acuity depends not just on the health of the eye but also on how well the brain processes the signals it receives. 6. Night vision. Our ability to see in low light is primarily controlled by rod cells in the retina, which are more sensitive to dim light but cannot perceive color. Secret. In dark conditions, we see mostly in shades of gray. The transition from light to dark environments takes time because rod cells need to adjust, a phenomenon known as dark adaptation. 7. Dynamic vision. This refers to our ability to track and focus on moving objects. It's vital for activities like driving or playing sports. Secret. Smooth pursuit eye movements allow our eyes to follow moving objects, while saccades are rapid movements that let us shift our gaze from one point to another quickly. 8. Focus and accommodation. The lens of the eye changes shape to focus on objects at different distances, a process known as accommodation. Secret. As we age, the lens becomes less flexible, leading to presbyopia, a condition that makes it harder to focus on close objects. 9. Peripheral color blindness. Although central vision provides sharp, detailed images and color recognition, color perception in the periphery is weak. This is because rods dominate the periphery and are not sensitive to color. Secret. While your central vision sees vibrant colors, your peripheral vision sees mostly in shades of gray. 10. Blind spot. There is a small area in our vision where we are completely blind. This blind spot is where the optic nerve exits the eye, and no photoreceptor cells are present. Secret. The brain fills in this gap with surrounding visual information, so we usually don't notice the blind spot in everyday life. 11. Visual adaptation, light and dark adaptation. When you move from a brightly lit environment to a dark one, your eyes adjust. Rods and cones adjust at different rates, with cones handling bright light and rods taking over in the dark. Secret. Dark adaptation takes longer because rod cells need time to become fully active after being exposed to bright light. 12. Binocular and monocular vision. Binocular vision, the use of both eyes to create a single image, critical for depth perception. Monocular vision, vision with one eye, where depth perception is weaker but peripheral vision might compensate. Secret. Some animals rely more on monocular vision, e.g., birds, while humans heavily depend on binocular vision for depth. 13. Afterimages. After staring at a bright image or color for a while and then looking away, you may briefly see a negative version of that image. Secret. This happens because photoreceptors in the retina get temporarily fatigued, and the brain compensates by showing a complementary color. 14. Foveal and macular vision. The fovea is the central part of the retina responsible for sharp central vision, crucial for activities like reading. Secret. The fovea contains a high density of cone cells and no rods, making it the area of the eye that provides the sharpest vision. Conclusion. There are many secrets or types of vision functions, from how we perceive color and depth to how our eyes adapt to light and darkness. Each of these components plays a vital role in how we interact with the world visually. The human visual system is highly complex and incredibly adaptive, making vision one of our most essential senses. I ask this along the lines of what you were asking? If you meant something else by secrets of eyesight, feel free to clarify. Yours, Psycho Philosopher.